Prior Analytics, Chapters 4 through 7. Aristotle's Study of Reasoning, explained. One of the most important concepts in Aristotle's logic is that of the middle term. In order to understand what a middle term is, let us begin by speaking metaphorically, and then we'll speak more literally. Middle terms are necessary because not all propositions are self-evident or immediate propositions. Self-evident propositions occur when two terms are immediately connected. They don't need some third term to connect them. Non-self-evident propositions, on the other hand, occur if two terms are not immediately connected. Thus, a third is needed in order to connect them. The two terms that are connected by this third term constitute the conclusion. The third term will be in the premises, and it will force the two terms in the conclusion to either be joined or divided. They'll be joined if the conclusion is an affirmative proposition, and they'll be divided if the... We could think about a middle term by imagining a bridge. One extreme, or one term, is not immediately connected to the other extreme, or the other term. This is what happens in a non-self-evident proposition. Thus, in order to connect these two terms or extremes, which will eventually constitute the conclusion of our syllogism, we need a middle term. The middle term is analogous to a bridge. An immediate proposition would be one in which the terms are touching each other. No bridge is needed. A proposition that's not self-evident, however, must be proved through a syllogism in which a middle term causes two terms, the two extremes in the conclusion, to be united to one another. The simplest syllogism will have three terms. Two terms will be joined or divided in the conclusion. The middle term is what causes the conclusion to join or divide the two terms in the conclusion. The middle term itself will not be found in the conclusion, but in the premises. Here's an example. Consider the conclusion, every dog is an organism. Here, organism, that is, the major term, is related to the minor term, dog. In the first premise, we relate organism to the term animal. In the second premise, we relate the term animal to the term dog. Thus, we have a syllogism. Every animal is an organism. That's the first premise. Organism here is related to animal. In the second premise, we say every dog is an animal. Here, animal is related to dog. Thus, there's a relation between animal and organism and between animal and dog. Thus, animal is related to both of the terms that appear in the conclusion, namely the conclusion that states every dog is an organism. Accordingly, animal is capable of uniting the two terms in the conclusion by means of its own relation to those two terms. Notice that organism is related to dog by means of its relation to animal and by means of animal's relation to dog. Thus, the conclusion has two terms which are forced to be related to each other in virtue of the way that some third term, namely animal, or the middle term, is related to the two terms in the conclusion. In this simplest form of syllogism, in which there are three terms, namely the two in the conclusion and the middle term, there are three ways in which the three terms can be arranged with respect to one another. These three arrangements are traditionally called figures. In the first figure, which is discussed in Prior Analytics Chapter 4, the middle term is the subject of one premise and the predicate of the other. In the second figure, the middle term is the predicate of both premises. This is discussed in Prior Analytics Chapter 5. In Prior Analytics Chapter 6, Aristotle discusses the third figure. In this figure, the middle term is the subject of both premises. Aristotle gives different definitions for what are called the middle term, the major term, and the minor term for all three syllogisms. But modern conventions specify that the middle term is the term not found in the conclusion, but found twice in the premises. This definition corresponds to the middle term in all three figures. The major term is the term that is the predicate of the conclusion. Something can be called the major term even when it is found outside of the conclusion and in the premises. For instance, the subject of the first premise in Figure 2 is called the major term because it is that same term which is the predicate of the conclusion. Likewise, the minor term is the term that is the subject of the conclusion. This term, again, can be called the minor term even when it is found outside of the conclusion. For instance, the subject of the second premise in Figure 1 is called the minor term, precisely because it is that same term which is found as the subject of the conclusion in Figure 1. The premises are called major or minor based on whether they are the premise that contains the major or the minor term. Traditionally, the major premise will be listed before the minor premise. It's a good habit to do this. Nevertheless, it actually makes no difference whether the major premise is listed before the minor premise or vice versa. Either may be listed in either order. Nevertheless, it is a good habit to list the major premise first and the minor premise second, just in order to help yourself remember the patterns. In Prior Analytics chapters 4 through 6, Aristotle will often give examples of the three terms in a given syllogism. When he does this, he lists the three terms in a different order depending on which figure of syllogism he's discussing. In the first figure, he will list the major term first, and then the middle term, and then the minor term. He will give the three examples separated from one another by dashes. In the second figure, he will list the middle term, and then the major term, and then the minor term. The major term in the second figure is therefore listed closer to the middle term than the minor term is. In the third figure, he will list the major term, and then the minor term, and then the middle term. Thus, in the third figure, the minor term is closer to the middle term than the major term, whereas, as we just saw in the second figure, the major term is closer to the middle term than the minor term. In the first figure, the middle term is equally distant from both the major and the minor term. Aristotle will also give different letters for the different syllogisms terms, depending on whether they are a syllogism in the first figure, the second figure, or the third figure. In the Loeb translation of Aristotle's Prior Analytics, he will use the letters A, B, and C for the first figure. He will use the letters M, N, and O for the second figure, and he'll use the letters P, S, and R for the third figure. While it's a good idea to stick to the letters that Aristotle chooses, again in order to remember the patterns, it is strictly speaking unnecessary to do so. Aristotle could have picked any other set of letters, and it would have made no difference to these figures. Loosely speaking, a series of propositions with three terms in one of these figures can be called a syllogism. This is how most modern textbooks of logic will speak about the syllogism. That is, they'll speak about syllogisms loosely speaking. A valid syllogism, they will say, is a syllogism in which the conclusion necessarily follows from the premises. Strictly speaking, the only kind of syllogism is a valid syllogism, because Aristotle has defined a syllogism as one in which the conclusion necessarily follows from the premises. Nevertheless, when we speak about syllogisms loosely, syllogisms can be divided into valid syllogisms and invalid syllogisms. A syllogism in general will be one in which there are three terms arranged according to one of these figures. A valid syllogism, then, will be a specific kind of such an arrangement in which the conclusion necessarily follows from the premises. An invalid syllogism will be one in which no conclusion necessarily follows. A sound syllogism is a syllogism that is both valid and has all true premises and a true conclusion. In other words, a sound syllogism must both be A, valid, and B, have all of its propositions, that is, both premises and the conclusion, be true. Syllogisms are usually not called true or false. Properly speaking, what's called true or false are the premises or the conclusion, that is, individual categorical propositions. The whole syllogism is called valid, invalid, or sound. The order of the premises does not affect validity, so you could list the major premise before the minor premise, or vice versa, and the validity of the syllogism will not be altered. Which letters are chosen to represent the variables, or the terms, is completely irrelevant as well for validity. For instance, I could represent the third figure with the terms A, B, and C instead of the terms S, P, and R. The valid syllogisms in the third figure, if we had used the letters A, B, and C, would just be as valid with those letters as they are with S, P, and R. Nevertheless, it's still good practice to put the major premise before the minor premise and to use the letters that Aristotle himself uses for the three figures. This is good practice merely for forming habits and for recognizing patterns, even though it's strictly unnecessary. Let's look at some examples of invalid, valid, and sound syllogisms. Here's our first example. Premise 1, no fish walks. Premise 2, some mammal does not walk. Conclusion, some mammal is a fish. Notice that the first two premises are both true. No fish walks is true. Some mammal does not walk is also true, because dolphins and whales are mammals but don't walk. The conclusion, however, is false. It's not the case that any mammal is a fish. This is clearly an invalid syllogism because the premises are true and yet the conclusion is still false. While it's not the case that every invalid syllogism will have two true premises, nevertheless, if we do find an arrangement of premises in which the premises are true and the conclusion false, that does guarantee that the syllogism in question is invalid. But surely if we replace these examples with other examples and kept the exact same arrangement of terms and kinds of propositions, then the syllogism would remain invalid, even though the examples were replaced. So how do we represent this syllogism without these particular examples, but in a general way, so that we show that this form of syllogism, or this mood of syllogism, in which the terms are arranged in such a way and the propositions are of such a kind, the syllogism in question must be an invalid regardless of which examples are plugged in? Well, we can do this by representing each premise and the conclusion using variables instead of examples. Premise 1 can be represented like this. The two capital letters are separated by a lowercase letter. The capital letters are variables corresponding to the two terms in the proposition. The first term is the major term. The second term is the middle term. The lowercase letter separating these two capital letters is E. That's because the kind of proposition in question is a universal negative proposition. So the two capital letters are variables corresponding to the two terms, and the lowercase letter represents the kind of proposition that relates these two terms. In this case, a universal negative proposition. The second premise can be represented again with two capital letters corresponding to the two terms, in this case a minor term and a middle term. The lowercase letter separates the two capital letters. The lowercase letter in this case is an O because the proposition in question is a particular negative proposition, and particular negative propositions on the square of opposition are represented by the letter O. The conclusion is represented in the same way. In this case, we have an I for the lowercase letter in between the two terms. That's because the conclusion is a particular affirmative proposition, and particular affirmative propositions correspond to the letter I. Any syllogism with this arrangement of variables and with these kinds of propositions, namely an E proposition, an O proposition, and then an I proposition, is going to be invalid. Since this is a second-figure syllogism, we can say in general that any second-figure syllogism that has a major premise that is universal negative, and then a minor premise that is particular negative, and then a conclusion that is particular affirmative, will be an invalid syllogism. Here's the second example. Premise 1. Every Shakespeare play is a musical. We could symbolize this first premise as such. We use the lowercase letter a to represent this premise because this premise is a universal affirmative proposition, and universal affirmative propositions correspond to the letter A. Premise 2, The Phantom of the Opera, is a Shakespeare play. Again, we use the letter A as a lowercase to represent this proposition because, again, it's a universal affirmative proposition. Conclusion. The Phantom of the Opera is a musical. We symbolize this conclusion as follows. Notice that this is a first-figure syllogism. A first-figure syllogism with all universal affirmative propositions. The conclusion is true. It is true that The Phantom of the Opera is a musical. The first premise is false. Every Shakespeare play is not a musical. The second premise is also false. The Phantom of the Opera is certainly not a Shakespeare play. So there are two false premises, but a true conclusion. This is a valid argument, but it's not sound. We know it's not sound because in order to have a sound argument, we must not only have an argument in which the conclusion follows, but it must also be the case that both premises as well as the conclusion are true. In this case, the conclusion does follow from the premises, but the premises are false, so the argument is not sound. Let's look at a third example. Every mammal has lungs. Some aquatic animal is a mammal. Conclusion. Some aquatic animal has lungs. This can be symbolized as follows. Here once again we have a first-figure syllogism. But in this case, the first premise is universal affirmative. The second premise is particular affirmative. The conclusion is also particular affirmative. In this case, we have a sound argument. That means our argument or syllogism is both valid and all of the premises are true and the conclusion is true. One important thing to note is that for valid and invalid arguments, if we know the variables the kind of propositions, and the figure of syllogism, then we know that the argument, regardless of which examples are plugged in for the variables, will be either invalid or valid depending on what we said about that arrangement of variables and kinds of propositions. On the other hand, the same is not true with regard to sound propositions. So, for instance, I've just shown that capital B, lowercase a, capital A, as one premise, and then a second premise as capital C, lowercase I, capital B, and then a conclusion as capital C, lowercase I, capital A, is valid. That argument must be valid in every case, regardless of which examples are plugged in. Nevertheless, depending on which examples are plugged in, this argument might not be sound. For instance, if I plug in examples which make one of the premises false or the conclusion false, the argument will still be valid. Nevertheless, the argument will no longer be sound. So validity attaches to variables and kinds of propositions regardless of examples. The same is true for invalidity. Soundness, however, depends on knowing what the variables represent. In other words, soundness requires that we replace the variables with examples. We cannot judge soundness merely by looking at an argument with variables. We can judge validity and invalidity merely by looking at an argument with variables. Besides dividing syllogisms into valid and invalid syllogisms, we can also divide syllogisms into perfect and imperfect syllogisms, or alternatively, complete and incomplete syllogisms. The syllogisms that are divided into perfect and imperfect are the valid syllogisms, or the syllogisms properly so called. Invalid syllogisms are not divided into perfect and imperfect. Only valid syllogisms are. Aristotle describes the perfect and imperfect syllogisms as follows, quote, I call a syllogism perfect if it requires nothing apart from what is comprised in it to make the necessary conclusion apparent. Imperfect if it requires one or more propositions which, although they necessarily follow from the terms which have been laid down, are not comprised in the premises. A perfect syllogism, then, is a syllogism whose conclusion follows immediately and necessarily from its two premises. An imperfect syllogism, on the other hand, is a syllogism, the conclusion of which follows necessarily from the premises by means of certain additional premises which are entailed by the two premises. Much of Aristotle's prior analytics is concerned with proving that certain arrangements of premises are either valid or invalid. They either produce a syllogism or do not produce a syllogism. How does Aristotle show that a syllogism is invalid? What he does is he shows that a certain arrangement of premises is consistent with both a positive conclusion and a negative conclusion opposed to that positive conclusion. Insofar as these opposing conclusions are consistent with the premises, obviously no conclusion necessarily follows from the premises. He shows that opposing conclusions are consistent with the premises by plugging in different examples for the three terms, such that with one set of examples, a positive or affirmative conclusion would be true, and with another set of examples, a negative conclusion would be true. How does Aristotle show that a syllogism is valid? Aristotle uses several methods. First, if a syllogism is perfect, he simply states the syllogism. He assumes that the validity of the syllogism, since the syllogism is perfect, will be self-evident. In other words, he doesn't need to prove that it's valid. We'll immediately see that it is valid by him stating what the syllogism is. The second way Aristotle shows the validity of a syllogism is with imperfect syllogisms. He does this by drawing the conclusion by means of a perfect syllogism. This happens in one of two ways. Either he converts one of the premises of the syllogism, that is, of the imperfect syllogism, such that the syllogism produces a perfect syllogism from which a conclusion follows, or he does this by an argument form called reductio ad impossibile. We will discuss this later on. Let's look at an example of Aristotle proving the invalidity of a syllogism. Here's the quotation. Again, if B applies to no C and A applies to some or does not apply to some or all of B, in this case, there will be no syllogism. We may take as terms white, horse, swan, white, horse, crow. Let's break this down since it's a very complicated passage, and indeed most of the prior analytics consists of complicated passages along these lines. Let's first look at the part of the quotation where Aristotle says, if B applies to no C. What does this mean? Well, Aristotle is just talking in a roundabout way of a proposition. B is the predicate. C is the subject. The word no indicates that we're looking at a universal negative proposition, since no is the quantifier that brings about a universal negative proposition when no is attached to the subject of the proposition, in this case C. So we could paraphrase what Aristotle says by saying no C is B. Now let's look at the part of the quotation where Aristotle says A applies to some or does not apply to some or all of B. What does Aristotle mean here? Well, here he's really talking about multiple propositions. We can tell because he uses the word or, implying he's including multiple kinds of propositions in one sentence or one phrase. The first is some B is A. This is what Aristotle means when he says A applies to some B. The second proposition is some B is not A. This is what Aristotle means when he says A does not apply to some or all of B. Let's ignore the second proposition and just focus on the first one. What does Aristotle mean when he says, in this case there will be no syllogism? Well, he means that the two premises, namely i.e., do not entail any conclusion. In other words, we can say that a syllogism with the premises I and E in the first figure will be invalid. More properly, or sticking closer to Aristotle's own verbiage, we will say that the premises do not produce a syllogism. That is, they don't produce a valid syllogism, one in which the conclusion necessarily follows from the premises. Were we to add a conclusion to the premises, that is, first figure premises of the kind I and then E, the result would be only an apparent syllogism, that is an invalid syllogism, not a real syllogism, that is a valid syllogism. What are we to make of the phrase where Aristotle says, we may take as terms white, horse, swan, white, horse, crow? Let's remember what we said previously in this slideshow. Aristotle will arrange examples for the three figures of syllogisms differently. In the first figure, he'll put the major term first, and then he'll put the middle term, and then the minor term. So the example of the major term here is either white in the first set of examples, or white in the second set of examples. The example of the middle term is horse in both sets of examples. The example of the minor term differs in the two sets of examples he's just given. In the first set, it's swan. In the second set, it's crow. Let's plug in these examples to the syllogism first figure with the propositions the kind I and then E. We get a positive conclusion if we plug in the first set of examples. Some horse is white. No swan is a horse. This, or these two premises, are consistent with the affirmative conclusion being true, namely, some swan is white. This conclusion isn't a true conclusion in the sense that it's drawn from the premises, but it's true in the sense that it's a true proposition. It's true that some swan is white, because indeed it's true that every swan is white. Nevertheless, this is not a real conclusion in the sense that it's not really drawn from the premises. It's just a proposition that has terms that make it look like it's drawn from the premises. The way we know this is because an argument of the exact same form, but with different examples plugged in for the variables, results in a negative conclusion that contradicts the one we just drew. Here's the negative syllogism. Some horse is white. No crow is a horse. No crow is white. Notice the conclusion here is again true. It's true that no crow is white. But the form of this proposition that constitutes the supposed conclusion contradicts the form of the conclusion in the affirmative syllogism. Some swan is white is an I proposition, that is, a particular affirmative. But particular affirmative propositions are the contradictory opposite of universal negative propositions. In other words, the form of syllogism in the first figure, in which we have an I proposition for the major premise and then an E proposition for the minor premise, is invalid precisely because it's consistent with contradictory conclusions. It's consistent with a particular affirmative conclusion, such as some swan is white, and a universal negative conclusion, such as no crow is white. Accordingly, no conclusion necessarily follows from a first figure syllogism with a major premise that is particular affirmative and a minor premise that is universal negative. Thus, we've shown, using Aristotle's method, that this kind of syllogism is invalid. Here we've written out the letters corresponding to the kinds of propositions within the syllogism. The first premise is I in both the affirmative and negative. The second premise is E in both the affirmative and negative examples. The conclusion in the affirmative example is an I. The conclusion in the negative example is an E. But I and E propositions contradict each other. So, once again, as we said before, a syllogism in the first figure with an I premise and then an E premise is consistent with contradictory conclusions. Aristotle, or we should say the editor of Aristotle's works, in this case the Loeb edition of Aristotle's works, puts the kind of invalid syllogism in the margins of the text. That's in this red square. The editor has put an I and then an E, indicating that a syllogism of the form I and then E within the first figure is invalid. The invalidity is indicated by the dash after the I and E. The dash indicates that no conclusion follows.
Recall that in the prior analytics, Aristotle has two tasks. First, he must show that certain combinations of premises within certain figures of syllogism are invalid. Next, he must show that certain combinations of premises within certain figures of syllogisms are valid. But among valid syllogisms, some are perfect, that is, self-evidently valid, and some are imperfect, meaning that they only draw a conclusion by means of entailing certain perfect syllogisms. Here, let's look at the perfect syllogisms. Each of these belongs to the first figure. The first perfect syllogism begins with the premise, every B is A. This can be represented in the following Venn diagram. The next premise is every C is B. This can be represented by a third circle within the Venn diagram. The conclusion is every C is A. If you look at the circles, it's obvious that this is true. If C is included entirely within B, and B is included entirely within A, then it follows that C is included entirely within A. The second perfect syllogism begins with a negative universal proposition, no B is A. This can be represented by two circles entirely outside each other. The second premise is every C is B. This can be represented by a circle within B. The conclusion drawn is no C is A. This is obviously already true from what we've already drawn for the premises. After all, if C is entirely within B and the circle B is entirely outside of A, then we don't need to draw anything more to see that C is entirely outside of A. The third perfect syllogism begins with the premise every B is A. The second premise is some C is B. We could represent this by putting an X somewhere within B. The X will be blue insofar as we've represented the minor term as blue. The conclusion that we draw is that some C is A. Obviously, if there's an X within the circle representing B, then there's also an X within the circle representing A, insofar as the circle representing B is entirely circumscribed by the circle representing A. The fourth kind of perfect syllogism is as follows. The major premise is no B is A. This is again represented by two circles entirely outside each other. The minor premise is represented as some C is B. Here we'll put an X within the circle B. This X will be shaded the same color as the minor term, C. The conclusion we draw is that some C is not A. Obviously, if there's an X within the circle B and the circle B is entirely outside of the circle A, then there's at least one thing that belongs to C that's outside of A. All of these syllogisms, which are perfect syllogisms, are in the first figure. That is, the figure in which the major premise has the middle term as the subject and the major term as the predicate, and in which the minor premise has the minor term as the subject and the middle term as the predicate. The traditional names for these syllogisms were given to these syllogisms in the Middle Ages. Aristotle himself did not give names to these syllogisms. These names are helpful for memorizing syllogisms that are valid. In each of these names, the important thing to note are the vowels. The vowels correspond to the kind of propositions in the premises and in the conclusion. So, for instance, A Barbara syllogism is a first figure syllogism in which the two premises are both A premises, that is, universal affirmative premises, and the conclusion is an A premise, or an A proposition, that is, a universal affirmative proposition. Likewise, the syllogism Kellerant is a syllogism within the first figure in which the major premise is an E proposition, that is, a universal negative proposition. The minor premise is a universal affirmative, that is, an A proposition, and the conclusion is an E proposition, that is, a universal negative. The third kind of perfect syllogism is called Dari. That's because its major premise is a universal affirmative, A, and the minor premise, as well as the conclusion, are particular affirmative propositions. Recall that the letter representing particular affirmative propositions is I. Finally, the fourth kind of perfect syllogism is called FIGURO. That's because if we look at the vowels and correspond them to the syllogism, we see that the major premise is an E proposition, that is, a proposition that is universal and negative. The minor premise is an I proposition, that is, a particular affirmative proposition. And the conclusion is a particular negative proposition, or an O proposition. Notice that within the first figure, we have perfect syllogisms proving every kind of proposition. That is, Barbara proves a universal affirmative, Kellerant proves a universal negative, Dari proves a particular affirmative, and FIGURO proves a particular negative. Thus, you can prove any kind of proposition within the first figure. Moreover, you could do so through a perfect or self-evidently valid syllogism. Here, I have given the symbolic version of each of these four perfect syllogisms. If we don't want to write the words every and is, we can just represent a Barbara as BAA, where the first A is lowercase because it represents the kind of proposition, and the second A is capitalized because it represents a certain term, and so on for the other premises and conclusions.
Now that we've seen what are the perfect syllogisms, let's consider how Aristotle proves the validity of imperfect syllogisms by means of perfect syllogisms. He does this using one of two methods, either the conversion method or the argument ad impossibile method. We'll take these methods in turn, starting with the conversion method. Here's the section we're going to be analyzing. Let M be predicated of no N, but of all O. Then, since the negative premise is convertible, N will apply to no M, but ex hypothesi, M applies to all O. Therefore, N applies to no O. Let's look at the part of the quotation we just read. Let M be predicated of no N, but of all O. This is really a short version of two propositions. The two propositions in question are no N is M, that is, let M be predicated of no N. And the other proposition is every O is M. This corresponds to the part of the sentence, but of all O. This gives us two premises from which we may or may not be able to draw a conclusion, namely, no N is M and every O is M. Now let's look at another part of the quotation. Then, since the negative premise is convertible, what this means is no N is M. But that premise, since it's negative and universal, is convertible. So just as if it's true that no N is M, then it's also true that no M is N. That's the conversion of the universal negative proposition. So let's perform this conversion in the two premises we have written down below. We convert the major premise, no N is M, such that it reads
no m is n. Now let's look at another part of the quotation that we read. N will apply to no m. What this means is that no m is n. But ex hypothesi m applies to all O. What this means is every O is m. That is a proposition we've already seen. Specifically, it's the minor premise from the two premises we put down, from which we were going to test whether a conclusion could be drawn or not. So let's put that second premise down. So we've converted the major premise, and we just carry over the minor premise unchanged. Now let's look at the last part of the quotation. Therefore, n applies to no O. This means no O is n. How do we get that? So consider the two premises. We've converted the major premise such that it reads no m is n. The minor premise is unchanged. But in such form, we have the premises of a Kellerant syllogism. Remember that Kellerant is one of our 4 perfect syllogisms. Thus, we can draw a conclusion via Kellerant. The conclusion is no O is n. That's the conclusion that follows from a Kellerant proposition, from a Kellerant syllogism. The middle term is m, the minor term is O, and the major term is n. The major term is the predicate in the major premise, and the minor term is the subject in the minor premise. Thus, through the two premises, no n is m and every O is m, we've been able to draw the conclusion no O is n. We had to do so by converting one of the premises to another premise that is entailed by that premise by itself, and then drawing a conclusion by means of one of the perfect syllogisms. Thus, a syllogism with the premises no n is m and every O is m is a valid syllogism, but it's an imperfect valid syllogism because it only draws its conclusion by means of a perfect syllogism which it entails. This imperfect syllogism is called Cesare. That's the traditional name for the syllogism. Aristotle himself doesn't give this syllogism that name, but in most editions of Aristotle, the traditional name will be written in the margins or in a footnote. Here, in this edition from which we've read our quotation, it's written in the margins. Now that we've seen the 4 perfect syllogisms, and we've also seen how to prove a valid imperfect syllogism by means of the 4 perfect syllogisms using the method of conversion, now we'll look at doing the same thing using a different method, namely the method of argument ad impossibile, or, in other words, argument to the impossible. Here's the section of the text we'll be analyzing. Again, if m applies to all n, but does not apply to some O, it must follow that n does not apply to some O. For if it applies to all, and m is predicated of all n, m must apply to all O. But ex hypothesi, it does not apply to some. And if m applies to all n, but not to all O, there will be a syllogism to the effect that n does not apply to all O. Here's the first part of the text we'll be analyzing. If m applies to all n, but does not apply to some O, what this means is really 2 premises. The major premise, every n is m, and a minor premise, some O is not m. Let's plug these 2 premises into the syllogism we're going to be evaluating. Here's the next part of the quotation. It must follow that n does not apply to some O. In this part of the quotation, Aristotle is stating the conclusion he wants to prove follows necessarily from the two premises he just gave. The conclusion in question is sum O is not N. But in order to prove this conclusion, he assumes the contradictory opposite of it. That's what he indicates when he says, for if it applies to all. In other words, suppose that every O is N. Every O is N is a universal affirmative proposition. That is the contradictory opposite of the particular negative proposition, sum O is not N. It is the particular negative proposition that Aristotle is aiming to prove, and in order to prove that it follows from the two premises he's assumed, he assumes the contradictory opposite of the conclusion he wants to prove, namely, every O is N. Now let's look at the next part of the quotation. And M is predicated of all N. In other words, every N is M. Notice we've already seen this combination of terms in a universal affirmative proposition. Aristotle here is just restating the major premise from the two premises he's trying to evaluate. So let's carry over the major premise. The next step for Aristotle will be to move up the assumption of the contradictory opposite of the conclusion he wants to draw, and to treat that contradictory opposite as if it were a premise in a new syllogism. When we do so, we form the syllogism Barbara. That is one of our 4 perfect syllogisms from the first figure. This syllogism would read, every N is M. That's the major premise from the two premises we're evaluating. The next premise would be, every O is N. That is the contradictory opposite of the conclusion we're trying to draw from the two premises we're evaluating. Next, Aristotle says M must apply to all O. In other words, every O is M. This is just a statement of what follows from both the major premise in the first two premises we're evaluating and the contradictory opposite of the conclusion that we're trying to draw from the two premises we're evaluating. But, ex hypothesi, it does not apply to sum. In other words, sum O is not M. Notice we've also seen this combination of terms in a particular negative proposition before. Aristotle here is just restating the minor premise from the two premises we're evaluating. What he's saying is that this minor premise is the contradictory opposite of the conclusion he's just drawn by means of the major premise and the contradictory opposite of the conclusion he's trying to draw. Thus, we've reached a contradiction. In other words, if we maintain both the major premise, the minor premise, and the contradictory opposite of the conclusion we're trying to draw, we reach a contradiction. Thus, we must deny the contradictory opposite of the conclusion we're trying to draw. Aristotle says, and if M applies to all N, but not to all O, there will be a syllogism to the effect that N does not apply to O. The proof is the same as before. Thus, we've drawn a conclusion. Since we've denied the contradictory opposite of the conclusion we want to draw, it follows that we've asserted the conclusion we want to draw, namely that sum O is not N. Thus, from the two premises, every N is M, and sum O is not M, we reach the conclusion necessarily that sum O is not N. In general, this method of drawing a conclusion using argument ad impossibile involves assuming the contradictory opposite of the conclusion we want to draw and showing that doing so results in a contradiction. Thus, we must deny our original assumption of the contradictory opposite of the conclusion we want to draw, and instead assert the conclusion we want to draw. In this case, the syllogism that we've proved is valid is traditionally called barocco.
This name can be located either in the margins of the text or in a footnote, depending on which edition of Aristotle you are reading. Let's conclude with a word of summary about Aristotle's Prior Analytics, chapters 4 through 7. Aristotle's Prior Analytics is one of the most difficult books to read. It is arguably the first work of symbolic logic ever written. For this reason, it is of enormous consequence for the history of philosophy and science. Using this rigorous method of proof, Aristotle shows, in the course of chapters 4 through 7, all of the valid moods of syllogism within each figure of simple syllogism. In other words, he shows which arrangements of assertoric premises among the four kinds of premises in the square of opposition within each figure is valid or invalid, perfect or imperfect. Aristotle also shows the properties or characteristics of each of the three figures in terms of what conclusions they are capable of drawing, what sorts of premises they are capable of validly employing, and whether or not each contains any perfect syllogism. He gives these characteristics or properties at the beginning of each chapter or at the end of each chapter, in which he discusses the figure of syllogism in question. In chapter 7, he relates the three figures of syllogisms one to another, showing how the second and third figure are, in a way, reduced to the first figure. That's because it is in the first figure alone in which we are able to find perfect syllogisms. Moreover, as we saw, the first figure is the figure in which we are able to draw conclusions of any kind in terms of the four kinds of propositions within the square of opposition. In the first figure, perfect syllogisms, we're able to draw a universal affirmative conclusion, a universal negative conclusion, a particular affirmative conclusion, or a particular negative conclusion. What's left in Aristotle's Prior Analytics, among other things, is to show how syllogisms are valid or invalid, perfect or imperfect, not with respect to assertoric propositions or assertoric syllogisms, but with respect to apodeictic syllogisms and problematic syllogisms. We won't discuss that in this video. Nevertheless, the assertoric syllogisms are the most important kind of syllogisms. And these syllogisms, both at the premises and the conclusion, are assertoric. You should have the four perfect syllogisms memorized. You should know their names as well as what they look like and what figure they belong to. You should also understand the three methods by which Aristotle either proves the invalidity of a certain syllogism, that is, proves that no conclusion follows necessarily from the premises, and by which he proves the validity of imperfect syllogisms, through conversion or through arguments ad impossibile. You need not memorize every single syllogism that Aristotle goes through in the Prior Analytics chapters 4 through 7. Nevertheless, you should know the perfect ones, and you should know the methods by which to derive imperfect or invalid ones by means of the perfect ones.